Hello guys, welcome to your channel Learning Point. Today we are going to see question number 20, which is of the miscellaneous exercise of the matrices chapter, which is a part of 12th Commerce new syllabus of the year 2021. The question says the sum of three numbers is 6. If we multiply third number by 3 and add the second number, we get 11. By adding first and the third number, we get a number which is double the second number. Using this information, find a system of linear equation and also find the three numbers using matrices. So, because I have to find the three numbers, I will assume let the three numbers be x, y and z. So I can say over here, according to first condition, sum is 6. So x plus y plus z is equal to 6. Let me give it as equation 1. According to second condition, we multiply third number by 3. 3z, add it the second number plus y, and it says we get 11. So this is equal to 11. We have to take 0x over here because using matrices, so we require all the three variables. Therefore, if nothing is there, so I consider this is 0x and give it as equation 2. According to third condition, adding first and the third number. So I get over here x plus z, get a number which is double the second number. So this is equal to 2y. Because we require all the variables on left hand side, so I transfer this 2y on the left. So I get x minus 2y plus z, that is equal to 0. That is your equation 3. Now when I solve these three equations, I will get the values of x, y, z. But the question says find the three numbers using matrices. So using matrices, guys, we are having two methods to find the values of x, y, z: inversion method and the reduction method. Over here, I will be solving it with the help of reduction method. So according to the reduction method, first step that we have to do over here is we have to express the equations as three matrices A, X and B. A is the matrix of coefficients of the equations on the left hand side of the equations. First is 1, 1 and 1. First row represents first equation. Second row will represent the second equation, 0, 1, 3. Third row, it will be 1, minus 2 and 1. X over here is the matrix of the variables, which is always a column matrix. So x, y and z. And this over here is the RHS values. So 6, 11 and 0. So because we want to solve it using the reduction method, so in this sum, I have to first convert this element into 0. So if I want this element as a 0, I have to subtract R3 changes to R3 minus R1. So in this case, I have to apply the transformation in the third row, and therefore the first and the second row elements will be just copied down as it is: 1, 1, 1, 0, 1, 3. X, y and z, all the variables will be copied down because transformations are not applicable on the variables, and on the right hand side we will just copy 6 and 11. Let us work out for the third row. I am having 1 minus 1. This is 0. Minus 2 minus 1 minus 3 1 minus 1. This is going to be 0. On the right hand side 0 minus 6. This is going to be negative 6. Now when I talk about the next element, what we have to do is we also require a 0 in this position. Now when I require the 0 in this position, again the transformation will be on R3, and the transformation is R3 changes to R3 minus negative 3 into R2. Either I can write it like this, or I can say R3 changes to R3 minus and minus plus R2. Whichever you use, both will be absolutely correct. But once again, in this sum or in this step, I have to apply the transformation in the third row. So first row and the second row, all elements will be as it is. Variables, as I told you, they will also be copied down as it is. 6 and 11 will also be over there as it is. When we are using the transformation, 0 plus 3 into 0. So I will get over here. We should write 3 over here. I missed that 3. So over here, this will come out to be 0 plus 3 into 0, which is going to be 0, minus 3 plus 1 into 3, that is also going to be equal to 0, and 0 plus 3 into 3, that is going to be equal to 9. On the right hand side, minus 6 plus 3 into 11, and that is going to be equal to 27. Now we have to once again multiply the matrices. 1 into x, that is x, plus y plus z. 0x, that is 0, 1 into y, that is y, 3 into z, that is going to be equal to plus 3z. 0x, that is 0, 0y, that is again 0, and plus 9z. This is equal to 6, 11, and 27. Now, because we want to find the values of x, y, and z, we will use by equality of matrices. The first equation, x plus y plus z is equal to 6. Equation 1. Y plus 3z is equal to 11. Equation 2. And 9z is 27. So this directly gives us the value of z, 27 by 9, which is actually equal to 3. So that is the first part of our answer. Now substitute in equation 2. So I get y plus 3 into 3. So I get y is equal to 11 minus 9. According to that, I can say y is equal to 2. That becomes your second variable value, guys. And in order to find x, we will say substitute y and z in equation 1. I get over here x plus 2 plus 3 is equal to 6. So in such a case, x is equal to 1.